Here in this problem, we need to obtain the derivative of the inverse tangent of the given expression with respect to cosine inverse of x squared. To begin with, we will make an assumption here. We will consider that u, which is a function of x, to be equals to inverse tangent of square root of 1 plus x squared minus square root of 1 minus x squared divided by square root of 1 plus x squared plus square root of 1 minus x squared. And we'll consider another function v, which is a function of x, and this will be equals to cosine inverse of x squared. Then what we'll do, we'll need to find out derivative of u with respect to x, and we'll find out derivative of v with respect to x, and then we'll try to find out the value of derivative of u with respect to v. Okay, now let's begin. But before taking the derivative of u with respect to x, we need to simplify this given expression. So let's begin with u of x, and we'll try to reduce it. So first here we will have to make an assumption here. So we will take x squared to be equals to cosine of theta. We'll take x squared to be equals to cosine of theta and replace it in a given expression. So instead we have u. Now u will become on a function of theta. So this will be equals to the inverse tangent of, so here we have square root of 1 plus, so x squared will be replaced with cosine theta. So here we have square root of 1 plus cosine theta minus 1 square root of 1 minus cosine theta whole divided by square root of 1 plus cosine theta plus square root of 1 minus cosine theta. Right. Now, here we will use an identity. We know that cosine of theta, so that's given by 2 times cosine squared theta over 2 minus 1, and we can arrange the terms to get 1 plus cosine theta, which will be equals to 2 times cosine squared theta over 2. Similarly, we can also rewrite cosine of theta to be equals to 1 minus 2 times sine squared theta over 2, such that 2 times sine squared theta over 2 will become equals to 1 minus cosine theta. So wherever we have 1 plus cosine theta, we'll replace it with 2 times cosine squared theta over 2, and we'll replace 2 times sine squared theta over 2 with wherever we have 1 minus cosine theta. So let's begin. So this will give us inverse tangent of, so we have square root of 2 times cosine squared theta over 2 minus square root of 2 times sine squared theta over 2, whole thing divided by square root of 2 times cosine squared theta over 2 plus square root of 2 times sine squared theta over 2. This will give us inverse tangent of square root of 2 times cosine theta over 2 minus square root of 2 times sine theta over 2, whole thing divided by square root of 2 times cosine of theta over 2 plus square root of 2 times sine of theta divided by 2. Now we can take square root of 2 as a common factor, and this reduces to inverse tangent of cosine of theta over 2 minus sine theta over 2 divided by cosine of theta over 2 plus sine theta over 2. Now our task will be to make this cosine theta over 2 minus sine theta over 2 divided by cosine theta over 2 plus sine theta over 2 equivalent to theta, so that we can reduce this. Now here what we'll do, we'll divide both the numerator and the denominator with cosine of theta over 2. Now that should give us inverse tangent of, so we have cosine theta over 2 divided by cosine theta over 2. Now we have 1 minus sine theta over 2 divided by cosine, so the ratio is the tangent function. So we have tangent of theta over 2 divided by 1 plus tangent of theta over 2. Now we will make use of an identity. So if we have tangent of a plus b, so that simply equals to tangent of a plus tangent of b. So that will be divided by 1 minus tangent of a times tangent of b. Now if we take a to be equals to pi over 4 and b to be equals to theta over 2, then we can rewrite our expression as we'll have tangent inverse of, so in place of 1 we will write tangent of pi over 2 minus tangent of theta over 2 divided by 1 plus we have tangent of theta over 2, which is multiplied to 1, and we know that tangent of pi over 4. So this is not pi over 2, this is pi over 4. Tangent of pi over 4 is also equals to 1. We state it here, tangent of pi over 4 is equals to 1. That means we can apply this particular property, and this will be now tangent inverse of tangent of pi over 4. So here we'll have, this is plus or minus, this will be plus or minus, and this will be minus or plus. So that will give a pi over 4 minus theta over 2. So this is u as a function of theta. So that means we now have u of theta equals to, so tangent inverse of tangent of pi over 4 minus theta over 2 will simply reduce to pi over 4 minus half of theta. So we started with the assumption that x squared is equals to cosine of theta. So that means theta will be equals to inverse cosine of x squared. So that means in place of theta, we can replace with the cosine inverse of x squared, and then we will get u in terms of x. So we'll have pi over 4 minus half times cosine inverse of x squared. So this is the reduced form of u of x. Now what we can do? Now we can take the derivative of u with respect to x. The derivative of u with respect to x will be the derivative of pi over 4. So that's a constant which will be equals to 0 minus half multiplied to derivative with respect to x of the cosine inverse of x squared. Now we'll make use of a standard result, the derivative with respect to x of the inverse cosine function. So that's equals to negative 1 over square root of 1 minus x squared. So that means we will now get, that will be equals to, we have negative half multiplied to negative 1 divided by square root of 1 minus x squared, but here we have x squared, so this will become x squared whole squared, but we'll also have to use the chain rule, so we'll multiply it to derivative of x squared. So this will give us 1 over 2, so this negative half and negative 1 will get multiplied to give us positive. 2 will be multiplied to 1 minus x raised to the power of 4 and its square root, and derivative of x squared, so that's simply equals to 2x. So the 2 and 2 goes away, and this gives us derivative of u with respect to x. So this will be equals to x divided by square root of 1 minus x raised to the power of 4. So let's label this as number 1. We considered our function v to be equals to cosine inverse of x squared. So when we take the derivative of v with respect to x, so that will be equals to negative 1 divided by square root of 1 minus x squared whole squared multiplied to derivative with respect to x of x squared, which is going to give us negative 2x divided by square root of 1 minus x raised to the power of 4. So this is derivative of v with respect to x. Our goal was to determine derivative of u with respect to v, which was simply finding derivative of u with respect to x divided by derivative of v with respect to x. The derivative of u with respect to x we obtained, which is x divided by square root of 1 minus x raised to the power of 4, and derivative of v with respect to x, so this will be the reciprocal. So we have negative of 1 minus x raised to the power of 4 divided by 2x. So here x and x gets factored out, and square root of 1 minus x raised to the power of goes away, and this leaves us with negative half. So this is the value of derivative of u with respect to v. So that means the value of our original derivative, So this will be equals to negative 1 over 2.